In this video, we are going to see what are different types of conic sections. You might have heard of these terms like circle. Definitely, you must have heard in your fifth or sixth standard. Then parabola. Parabola, you might have heard when you did your quadratic equations, graph of quadratic, because graph of a quadratic function looks like a parabola. Then we have something called ellipse. Now, the planet Earth rotates around the sun in an elliptical path. Then we have hyperbola. Now, the thing is, these four figures are called conic sections. But why? Why the hell they are called conic sections? Why not square sections? Why not quadrilateral sections? Why are they called conic sections? So to explain that, first we will see the shapes of these four figures. I'm going to draw the shapes. I'm going to try to draw the shapes. So the circle is, you guys all know how a circle looks like. Then we have ellipse. But I think ellipse is not here. I'm going to draw. No, not ellipse. Then there is parabola. Parabola kind of looks like this, right? And you can shift it to the right, left, up, down, or you can change its orientation. Then the ellipse, as I mentioned, that planet Earth revolves around sun in an elliptical path, right? So this is kind of the ellipse. Wow, it came out pretty neat. And then there is hyperbola. So hyperbola is kind of two parabolas. So oh my God, I'm impressed by my drawing skills, especially when I'm using a digital pen and tablet. So these are your circle, parabola, ellipse, and hyperbola. But as I mentioned, why are they called conic sections? So to explain that, I thought of showing you a video because you will need to visualize this concept in 3 dimensions. Right now, on this blackboard, I can only show you things in 2 dimensions, but you know, a cone. So a cone looks like this. I will try my best to draw this. So this is a cone. Actually, this is a double cone. And just imagine that you have a you have a plane and you just keep cutting the sections of this cone. Let's say you slice this cone by a plane like this, and you are seeing from the top of this cone. So what is the figure that you will see over here? You will actually see a circle. You're cutting you're cutting this cone exactly parallel to the base. Okay, this plane is not getting tilted. If it is exactly parallel to the base, you will see that there will be a circle. Okay, I hope you can imagine it, but don't worry, we will watch a video. Then if you just tilt this, let's say you tilt this plane, then you will get some other figure. Then if you keep it at a certain angle, then you'll get some other figure. And if you keep the plane like this, then you'll get hyperbola. So let's just watch a video.
When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface obtained is called A double right circular cone. A double right circular cone consists of two cones joined at a fixed point called the vertex. Conic sections. If a plane intersects a double right circular cone, we get two-dimensional curves of different types. These curves are called conic sections. Depending on the angle made by the plane with the vertical axis of the cone, the plane can cut the cone in three different ways. Ellipse. When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed curve called an ellipse. When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, a circle is a special type of ellipse. Parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. Hyperbola. The plane intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. However, if the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has two disjoint curves.
All right, so these were our four different types of conic sections. And in the next video, we'll see different properties of this conic sections.